So, welcome to our first Stats 270 class. I have checked online. This class is on EKU Direct, and it shows up on my Blackboard site. So we are official. This is going to be our class for this semester. I have spent my entire weekend, and I have your syllabus done and 4 sets of notes typed up. So I'm only a week ahead. I had an entire semester done for calculus, but I'm not that lucky right now. But I'm going to work on it. So with this class, our videos will actually cover 1 set of notes per video because they are going to be considerably shorter than what we would have encountered with the calculus class. So we're not going to be splitting these up. We have a lot of material to cover to meet the requirements for the course. So we'll discuss the syllabus in detail on Monday. Some of you may watch this video tonight. That's why I'm mentioning that it will be on Monday when we talk about the syllabus. So I just want to go ahead. We'll jump right in. We'll talk a lot more in class about some of the things we're going to cover today. This is going to be a very reading heavy class. There's going to be a lot of word problems. We've already discussed that. And there's going to be a lot of interpretation. Yes, there will be some considerable math as we move forward, but right now we need to establish a foundation and a groundwork of what statistics encompasses. So you can see from the beginning of this, we're just talking about the statistics basics. And a lot of you already know a lot about statistics. We talked about this on Friday in class. If you get on the internet and you see a survey or a study, if you read the newspaper, if you watch the news, if you follow sports, I even mentioned on here even the Bengals, my poor sad little Bengals. You hear the word statistics frequently, and we're going to talk about 2 primary types of statistics, descriptive and inferential. And what I want you guys to be aware of is there's a lot of stuff that I will gloss over in these notes, but I do want you to make sure that you read through these, highlight some of the important things. There's some little mini examples in here that I don't really highlight as examples. An example of that would be right here where it says descriptive statistics. I talk about the 1948 baseball season, and you can see that we take the statistics, especially from baseball or sports in general, and they are actually what we would call descriptive statistics. And descriptive statistics organize and summarize information. And you can see that in our definition here of descriptive statistics. It consists of methods for organizing and summarizing information. We don't make any predictions based on the information. It's just simple statistical analysis. This is exactly what happened, for example, with Bud Stewart up here, where we highlight Bud Stewart. It says his batting average was .279. We have taken into account all of Bud Stewart's at-bats and all of his hits. We're not taking a sample of his at-bats and his hits. We have compiled all that information. So that is a descriptive statistic. It describes his batting average exactly. Inferential statistics, we talk about making predictions based off of these statistics that we gather. I talked about Bud Stewart and the Washington Senators in 1948, so let's just stick with the 1940s here and talk about the 1948 presidential election. I'm sure many of you have seen in a lot of history books the picture of Truman holding up the newspaper that says Dewey defeats Truman, I believe is what it says. But the reason that picture is so famous is because it wasn't true. And the reason that newspaper headline was published was because of statistics. Prior to the election, it was predicted that Truman would only win 44.5% of the vote, which would not be enough for him to win the election. And so many outlets predicted that Thomas Dewey was going to win that election. However, that's not the case. There were many errors that were discovered in the analysis following, I guess you could call it an autopsy of what happened with the statistical analysis after that election. And so the Gallup organization did a lot of modifications of their procedures, and Funny enough, they predicted the winner of the presidential election every single time, with the exception of the 2016 presidential election. And that we talked about that in class as well. There was an overwhelming sense that Hillary Clinton was going to win that election, and as it turns out, yes, she did win the popular vote, but the electoral college votes is what decides the presidency, and President Trump was the one who obviously took the majority of the electoral college votes. So since the Gallup organization has been around, they have failed on 2 presidential elections, and I'm sure I've not really read too much up on it since typing these notes, but I'm sure that they have since gone back and done another autopsy on their procedures to avoid another mistake like they had in the 2016 election. So, political polling provides an example of inferential statistics. You can't interview everybody in the United States to find out what their voting preferences would be. I mean, that's the election itself. But if you interviewed everybody in the United States to get a prediction of what may happen in the election, it's both expensive, it's time consuming, and it's also unrealistic to even consider that that would be a possibility. So rather than doing that, a lot of these polling organizations like the Gallup poll, they take samples of the population. So perhaps what happened in the last election, the population samples that they used weren't representative of everybody in the United States, and that's why they got their information wrong. So population and sample are our next 2 keywords that we're going to look at in statistics. Population is the entire group that you wish to study. Sample is a small representative portion of that group, and that small representative portion can hopefully provide you information about the population as a whole. We mentioned inferential statistics. We've already defined descriptive. So here's a formal definition of inferential statistics. It consists of methods for drawing and measuring the reliability of conclusions about a population based on information obtained from a sample. We're drawing conclusions about an entire group based off of a sample of a much smaller group that's supposed to represent that population. So that's how you'll kind of understand the difference between descriptive and inferential. Differentiating between descriptive and inferential statistics, it's important to note that a descriptive study may be performed on a sample or on a population only when an inference is made about the population. So only when we make some statement or claim about the population itself do we move from a descriptive statistic into an inferential statistic analysis. So our first example, we're going to classify the type of study. So here we have the voting results of the 1948 election. All 5 candidates are listed along with their vice presidential running mate, the number of votes they won, and the percentage of the votes that they won. So we want to decide, is this a descriptive or is this an inferential study? So think about it for just a second. Hopefully you are saying that it is a descriptive study because we're not making any predictions based off of the information given. The vote column, that's the actual votes received. The percentage column is the exact percentage of votes received. We're making no predictions based off this information. So this is what we would consider to be a descriptive study. It describes the results of that election in detail. So example 2, we talk about something a little bit different. So I'll go ahead and read through this, but from 1876 to 1977, the Major League Baseball, they purchased baseballs from the Spalding Company. In 1977, Spalding quit manufacturing baseballs, and the MLB turned to the Rawlings Company for their new baseballs. So early on in the 1977 season, the pitchers began complaining that the balls were more lively than the balls that they had been accustomed to using from Spalding. They claimed that the balls were harder, they bounced farther, and they were faster, and that it gave hitters an unfair advantage. So just a quick analysis of the 1977 season showed that in the first 616 games, there were 1,033 home runs hit. compared to only 762 home runs in the first 616 games of the 1976 season. So we're looking at over 400 more home runs from one year to the next. And right now, the only difference is the baseballs. So Sports Illustrated conducted a study, and I actually am posting this on the website, the entire study, the paper, if you want to read it. There's going to be several articles that I will post. You're not required to read them, but I hope that you would, maybe to get a better feel for what we're discussing in class. The article was entitled "They're Knocking the Stuffing Out of It," and they had an independent testing company that selected 85 baseballs from the supplies of various major league teams, and then they measured the bounce, the weight, and the hardness of those chosen baseballs, and then compared them to similar tests from previous years and in previous seasons. And their conclusion was that the 1977 Rawlings ball is livelier than the 1976 Spalding, but not as lively as it could be under MLB rules or as the ball had been in the past. So based on that information, how would you classify this study? Well, this study is going to be an inferential study because they took a sample of the baseballs and they used that small sample to make a broad prediction or statement and conclusion about the entire population. So this is going to be an inferential study simply because we used a sample to make a prediction about the entire population. It really wouldn't have been reasonable to for this independent testing group to test every single baseball that every team possessed. That'd be somewhere, I think I read something about over 300,000, maybe 350,000 baseballs to test, and that's not feasible. It's going to be costly. It's time consuming. It's just an ineffective study. So we use this inferential study to make a prediction or make a statement based off what we observed with the 85 baseballs that they sampled. This is just a kind of a historical rundown of statistics. They've appeared since all the way back in ancient Rome, and then over the centuries they have developed into more precise and more detailed studies, census records, birth records, death records, marriages, even taxes. So this is where we get descriptive statistics from. Inferential statistics is relatively newer. It's developed more over the last century or so, and it's really evolving a lot more. But also it has to evolve because there's a lot of errors that can be made with inferential statistics, just like when we looked at the presidential prediction for the Gallup polls. When we talk about observational studies and designed experiments, that shouldn't be too hard to differentiate between. With an observational study, you're just simply observing a population or a sample of the population and seeing what happens. You're not trying to manipulate it in any way, shape, or form. You're not trying to change anything. With a designed experiment, it's exactly what it sounds like. You have an experiment that you are testing a hypothesis with, and so you set up these categories that you want to test. You have your control groups and things like that. So that's something else that we want to be able to differentiate between. So we have descriptive statistics and inferential statistics. Now we want to look at the two different major types of studies, which are observational and designed experiments. So our third example that we're looking at, we are going to categorize this study as either an observation or a designed experiment, and it's talking about approximately 450,000 vasectomies are performed each year in the U.S. Several studies have been conducted to analyze the relationship between vasectomies and prostate cancer. There was a study that was conducted at one point, and the doctor that did the study said that he found 113 cases of prostate cancer among 22,000 men who'd had a vasectomy. And that compares to a rate of 70 cases per 22,000 among men who did not have a vasectomy. So his study shows that there's about a 60% elevated risk of prostate cancer for men who have had a vasectomy, thereby revealing an association between vasectomy and prostate cancer. But does it establish causation? Does the vasectomy cause prostate cancer? Does having a vasectomy cause an increased risk of prostate cancer? Why or why not? So this is one of those cases where simply saying yes or no is not going to be enough. We have to explain why we want to say yes or no. And in this case, we can safely say, no, there is no causation. No, having a vasectomy does not seem to cause an increased risk in prostate cancer, because this was simply an observational study. This was not a designed experiment. They simply just compared two groups of men who had already either had the surgery or not had the surgery. They didn't establish experimental parameters. They just went out and checked for, well, a total of 44,000 men, half of which had vasectomies and half that did not. The other thing that they didn't establish were the other factors that could have possibly led to the increase in prostate cancer among these men. So this will be a hard one to actually say yes, it indicates causation, or yes, it indicates there's an increased risk of prostate cancer. But we're going to answer with no, the study was observational. No true link between vasectomies and prostate cancer can be established. And I will clean these notes up when I post them finally on the website. My handwriting gets a little sloppy as I try to do these videos because I try to write too fast. The fourth example: for several years, evidence had been mounting that folic acid reduces major birth defects. Two doctors, Dr. Zeisel and Dr. Dudas of the National Institute of Hygiene in Budapest, conducted a study that provided the strongest evidence that we have to date. Their paper, Prevention of the First Occurrence of Neural Tube Defects by Periconceptional Vitamin Supplementation, it's also on the website, and it can be found for your reading pleasure, because I'm sure you're going to jump right on that one. For the study, the doctors enrolled 4,753 women prior to conception, and then they divided them randomly into two groups. One group took daily multivitamins, one that the multivitamin did contain 0.8 milligrams of folic acid. The other group only received trace elements such as copper, manganese, zinc, and vitamin C. They did note in their study that there was a drastic reduction in the rate of major birth defects with the women who took folic acid, 13 per 1,000, as compared to 23 per 1,000 for those who did not take folic acid. Does this study imply causation? And in this study, we can say yes, it does imply causation, because they set up an experiment. It was a designed experiment. That's how we can establish causation. Now, is it going to be just like blatant, absolute causation? Not necessarily, because granted, it's 13 per 1,000 for the women who took folic acid compared to 23 per 1,000 for those who did not take folic acid. It's not a huge increase, but it's enough to make us sit and wonder, is the folic acid really at the necessary medicine to take, or the supplement to take rather, to decrease the incidence of birth defects. So in this one we can say yes, this is a designed experiment. That gives evidence of causation. So this is our basic quick overview introduction to statistics. Really, it's not going to be, if you can grasp the foundation and the fundamentals and the terminology that we have to go over in this class, then the rest of it's going to be really easy. Learning the math is going to be it shouldn't be a problem. We're going to use Microsoft Excel quite a bit. We're going to use our calculators a lot, and there's a lot of features on the calculators that will make this really simple. So we have our homework problems here. These homework problems will be due next Monday. So making this video on Sunday night, so tonight's the 12th. So they're going to be due on January the 20th. You really shouldn't have any problem at all getting these done within a day. But I'd just like for you guys to be able to break it up and do it in manageable chunks. Maybe go ahead and do the definitions tonight, and then maybe do 1 or 2 problems. Actually, you don't have, but 3. Oh, there's 2 pages of problems. My bad. Yeah, so break it up if you want to, and just kind of try to get a feel for what we're doing here, learn the terminology, and you guys are going to be great. I hope everyone had a great weekend. I am going to spend the next hour and a half maybe relaxing finally. So I will see you guys in the morning. Take care.